in this problem, assume there are 4 different type of experiments of bacteria that are growing and shrinking in a science class. So there's 4 different ones. You have 1, 2, 3, 4. How many days the experiment is going on is t, and the number of bacteria in the experiment is f of t. Assume they're all linear. That's a mistake. That should be exponential. It should be exponential, just so you know. So for this one, we are given the equation. What are we given here? The graph. Here we're given the sentence, and here we're given the table. So from this, you can use a calculator. You might want to. From this problem, we got to decide which of these would be easiest to start with. I honestly think the sentence is easiest. Let me describe why. Isn't this your beginning amount of bacteria?
Yes, sir.
And isn't this have the rate of change in percent?
Yes, sir.
So watch. This bacteria that we're measuring in a science class started with 20. Somehow they judge. They look in through the magnifying glass or not even telescope, microscope, and they notice there are 20 bacteria. So we start with 20 bacteria. And is it growing or shrinking? Look at this. Does that tell you if it's growing or shrinking? Doesn't that tell you it's growing since it's bigger than 1? Does it also tell you the percent? Isn't this 25 cents, which is 25%? So it starts with 20 bacteria and is growing, and growing by 25%, and T stands for days. So what you're doing here is that's your beginning, and that's, because it's bigger than 1, a growth of 25% each day, because that's what the problem's saying. Alrighty, so I got my sentence. I now need to do one of these two. Well, wouldn't the table probably be easiest to start with?
Yes, sir.
And isn't the 0 term really just that number?
Yes, sir. Yeah.
So I start with 20. Then I am plugging in 1. Well, 1 means I'm going to take 20 and multiply by 1.25. So on a calculator, we're just going to go 20 times 1.25. Or you could do it by hand. Let's see what we get. So right here, we're going to take 20 times 1.25, and we get 25. Now we're going to take 25 and multiply by 1.25.
Oh.
And you get 30 what? 31.25. So right there is our pattern, is our sequence of numbers. Now we need to graph it. Now if we look over here, our graph is in the first quadrant, so we're going to do a first quadrant graph. Since my biggest one is 31.25, and I have, let's go by, would 5 look like it work?
Yes.
It might be off a little bit on this last one, but can we go a little bit above?
Mm-hmm.
So if I go by 5s, I think I'll fit decently. So I'm going to go 10, 20, 30, which is by 5s. And then I'm going to plot these dots. So at 0, I have 20. At 1, I have 25. And at 2, I have 31.25, which is a little bit above. And there we go. Now, why did I not graph the negatives? Well, can I have negative time? Would the negatives not make a lot of sense? The negatives are kind of pointless for this problem because they don't make a lot of sense. Now there's my curve. It looks very linear, but it does slightly curve. For this one, I have the graph. So let's put the dots down real quick. There's a dot right there. We're going by 1s. I'm going to put 1 here, 2 here, 3 here so you can see it better. This one right here, is that a 2?
Yes, sir.
And does that look like 4 right there?
Yes.
But a couple dots, because we can't really see it perfectly. But from that, can you simply transfer that to the table?
Yes, sir.
At 0, it was 1. At 1, it was 2. And at 2, it was 4. So what we did is we transferred our graph onto the table by looking at the nice, good, clean spots at 0, 1, and 2. Now, let's make either the equation or the sentence. It's our choice. I'm going to start with the equation. isn't 1 going to be your first piece? So we're going to put 1, something to a t power. So 1 is our first thing. Do we really have to put the 1? Not really, because a 1 would have been, that's just is there, but we'll put 1 just because that's what it was. But right here, how do we find our common ratio, our growth factor? Well, don't we take this and divide by the previous? So take 2, divide by 1. Let's look at that. Our R, which is our common ratio, is 2 divided by 1. The second divided by the first, which is what? 2. Now, does that make sense? Let's stop and think. Are we doubling? Are we starting with 1 and doubling?
Yes, sir.
So as of what we see, that actually makes sense. So now we want to make the sentence. So from this, can we think of the sentence? Doesn't it say what we start with and how we're changing? So I'm going to say we start with how many bacteria? You started with 1 bacteria. They saw 1 single, very small bacteria. And is it growing or shrinking? It's growing by, oh, what percent is that? Well, it's doubling. Can I say it's doubling? Could I use the word it's doubling every day? Yes. Or could you see that as 100% growth? Now, how did I know that's 100% growth? Well, how far is 2 from 1? 1. Isn't 2 1 from 1? So 1 is 100% growth. Now, could I also, instead of this, put it doubles every day? Is that clear? Did you know that doubling is 100% growth? 100% of it the next time. That's what doubling means, 100% growth. So did we fill this whole box? Did we fill this box? Now we're down to here. So for this one, we have the sentence. So from a sentence, would it be easiest to go to the equation? I kind of think so. That'd probably be the easiest to go. So these bacteria started with 100 cells. So does that tell us the first number? And it's, shrinking. Be careful there. Shrinking for the first shrinker. That kind of sounded weird, but the first one that's shrinking. And how much is it shrinking by? 20%. So be very careful. This is shrinking by 20%. So if I have 1 minus 20%, what does that give me? Isn't that 0.80 or 0.8? So wouldn't that be 0.80 or 0.8? Could I put the 0 or not? Does the 0 matter?
No.
No, but for some people it might help to see 0.80. So let's think about that again. Be very careful. It's shrinking by 20%, so I have to subtract 20% from 1. So that's a 0.8 in there as the common ratio. It's 0.8. So I now have the equation and the sentence. All righty. So let's make the table. And then, because that's probably easier to do the table before the graph. So do we know our 0 term? Well, isn't it the front guy? Or it says here what you started with. So I started with 100. And it's saying you're taking 20%. So to get 1 here, aren't we going to take 100 times 0.8 once?
Yes, sir.
And are you okay? That's, I can't write, 80. 100 times 0.8 is 80. Then what we need to do is do 80 times 0.8. What's 80 times 0.8? Is it 64? Is it 64?
Yeah.
Yeah, 64. So these bacteria start with 100. Next day there's 80. Now there's 64 bacteria. It's shrinking by 20% each day. Slowly decreasing. So these are dying. These are growing, which happens. Depends on the atmosphere, the environment for the bacteria. Can we now plot these? Well, yeah, I have to go to 100. So to get to 100, should I go by, will 10s work?
20.
10s won't match. Will 20 or 25s? I'll go with 20s. It gives me more space. So let's go 20, 40, 60, 80, 100. 1, 2, 3, so forth. And we are going to put 100 at 0, then 80 and then 64, which would be a little bit above 60. And then can you graph it? Now, do you understand it has a curvature to it? Now, I want you to think about something. Will this graph ever get to 0? If it keeps shrinking by 20%, will there always be a little bit left? So at some point, this scenario doesn't make sense. Because will the bacteria sooner or later die, all be gone? But this graph would never get to 0. So at some point, once you get past 1 bacteria, is the graph done? Unless you have a partial bacteria. So just think about it. This is going to keep shrinking, shrinking, shrinking. Sooner or later, it's going to get to almost 0, basically, into the decimals. And then we'll kind of say, we're done with this graph. But that's just an extra piece. So we got growing, growing, shrinking. We're now here. We have a table. What do you think? Is it growing or shrinking? Shrinking. Can you see it shrinking? So from this table, do you want to do the sentence or the equation? Well, I'm going to do the equation. Isn't 200 go first?
Yes. Yes, sir.
200 always goes first. How do you find the common ratio? Well, don't you take the 140 and divide by 200? Okay, remember that, hopefully. You take this first term, divide by the 0 term, or you take the right, divide by the left. And when you reduce that, that will give us our common ratio, the number right here. So when you divide 140 divided by 200, you get 0.70. So that also reminds you of the decay. Shouldn't it be less than 1 for decaying? Okay, let's write our sentence. I want to do a sentence. What do we start with? How many bacteria? 200. So we started with 200 bacteria. And we are growing or shrinking? It's shrinking by what percent? Be careful, it's not 70%.
30.
Can you tell it's 30%? Can you picture missing that on the test?
Yes, I can.
30% each day or week. Our T stands for days or weeks. If you remember in the beginning, it's days. So we started with 200 and it's shrinking by 30% each day. Because 30%, it's 0.3 away from 1, which is a 30% decay. Be careful. A lot of you will put 70%. It's just, you just make mistakes. And can we make the graph now? I got 200. What do you guys think? Should we go by, we can't go by 20s. You want to go by 40s?
You can go by 50s.
Or 50s? Or I'm going to go by 40s. Is that okay? You can go by 50s. I'm going to go by 40s. Should work. 40, 80, 120, 160, 200. 1, 2, 3. And we have the first one is 0, is going to be 200. Then at 1 we have 140, which is right there in the middle. And then we have 98, which is a little bit less than 100. And then you got to graph this bad boy. It should have a little curve to it. It's kind of hard to see exactly what it looks like, but you have a dropping. Looks like that. So what you should notice is I have 2 growths and 2 decays. It's kind of nice. You have the pictures to help you. You have everything. You have everything about it. You have 4 different ways to interpret each scenario, which gives you a very strong understanding of each scenario. Alrighty. So which bacteria are shrinking? Well, can you look at the graphs or the equations? Are there lots of things you can look at? But can you say it's 3 and 4? Okay. Which bacteria are changing the fastest? Now, when I say changing the fastest, do I care if it's shrinking or growing?
No.
No, I just care what's the percent. Do you catch that? I don't care if it's negative or positive, up or down. I just care is which one's changing the quickest. So either it's dying fast or it's growing fast. Either way, which is the fastest change? So let's look at percents. We have 25. We have 100, 20, and 30. So which one's biggest? 25, 20, 30, or 100? Number 2 is way fast. I mean, it's like annihilating everything else. It's 100% growth. So number 2. Next, last one. Which bacteria is changing the slowest? Oh, same question, just opposite. So which one's the slowest change? Isn't it this one right here? 20%? Isn't that the smallest? Isn't 20% the smallest of all of them? So that would be 3. Next one. Which bacteria will have more after 10 days? So 10 days. So if you kept this pattern going for 10 days, which one will have the most? Now your initial would probably be the growing ones, right? But what if one of these shrinkers started really, really, really big? If it started really big, could a shrinking one still have more than one that's growing? It's possible. Got it? It's possible. But looking at the data, which one do you think will have more after 10 times of growth? Okay. Now, doesn't this grow the fastest? So is that your first bet? It's starting off small, only with 1. This one's growing quite a bit slower, 4 times slower. Would most of you agree this will probably have the most? Because if this one's already at 98 and this is at 64, after 2 turns, won't this get pretty quick, pretty darn fast? Sorry, big, pretty darn quick. And this one will get big quick too, but not as fast as this one. So at a glance, are you pretty sure it's 2? Now, if you wanted to make sure, could you technically plug 10 here, 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 and here on a calculator and see which is bigger? You could, just one by one, or graph all of them and look at a table. That's if you want to know for sure, but it's a pretty good bet because this is growing so fast, it's probably going to be that one. But it could check by plugging numbers in. Last question, which bacteria die off first? Well, it's probably the ones that are shrinking. Is that the first guess right here? If it's going to die off, it's probably something shrinking, not the top 2. So can I ignore the top 2? These guys are growing, so that doesn't make any sense. So which of these 2 do you think would die off first? Would it be the one that's shrinking the fastest?
4.
So isn't this guy shrinking faster? Even though it started twice as big, do you think it's going to die off, meaning less than 1 bacteria, first? What do you guys think? Look at these 2 numbers at 2. Do you think this guy is going to die off first? I think it's going to be 4. How would you check? Well, could you use a graphing calculator to graph both of these and see which one hits 1 first? Because the moment it hits 1, after that, you have nothing left. So we're looking at these if you want to be specific, but I think it's going to be 4 because 4 has the biggest shrinking mechanism. And the difference here is not a lot. When we look at the pattern, it seems like this one's going to be quickly dropping, even though it's not close enough yet, but it slowly would catch it. Quickly will catch it. So make sure you answer all these to answer these questions at the bottom.